Howdy folks, it's Mr. Ryan, and right now we're going to talk about the equation of a linear function. Now a linear function, hopefully you've already seen my video on graphing a linear function. If not, you may want to watch it, or you can watch it after this one, but I'm going to assume that you already have seen how to graph a linear function. But linear functions can actually be represented in three different main forms. There's the slope-intercept form, slope-intercept form. Then there is the point-slope form, point-slope form. And then lastly, there is standard form. Now for now, we're not really going to talk about standard form, but just so you know, standard form looks like this. It's some number a times x plus some number b times y is equal to some number c. That is the standard form of a line. This is very popular when doing a system of equations. It's very popular to put, oftentimes essential, to put an equation in the standard form of a line. But when we're graphing functions or when we're doing other things with linear functions, we often use slope-intercept form or point-slope form, both of which include the letter m as a slope. Now, if you've already seen my video on graphing a linear function, you know that the slope-intercept form comes in the form y equals mx plus b, okay, where m is the slope and b is the y-intercept. Okay, so that's the slope-intercept form. And point-slope form looks like this. Point-slope form is y minus y1 is equal to m times x minus x1. Okay, where, so by the way, so over here, m is slope and b is the y-intercept. Now in point-slope form, there's no y-intercept. There is a slope though. We have m is slope and the ordered pair x sub 1 comma y sub 1, or just x1 y1, this is a point. It's a point on the coordinate plane. So if you know what the y-intercept is and you know what the slope is, it's easy to put the line in slope-intercept form. But if you don't know what the y-intercept is, let's say you know the slope of the line and you know just one point that the line passes through. Out of all the infinite number of points that it passes through, you know one of those points. Well, that point would then be x1, y1, and what you would do is you would just write up the equation, the letter y, you're not going to put a number here, you're just going to put the letter y, minus, and then here for y1, you're going to put the y-coordinate of that point you're dealing with, okay? Equals m times, parenthesis, x, you're just going to put the letter x there. So for m, you're going to put a number here also, okay? You're going to put the slope, whatever the numeric slope is, you're going to put it right there. Then you're going to put the letter x here, minus, and then x1 is a number, okay? So x1. So let me show you an example. Let's say that you happen to know that the slope of a line is 5, and you know that the point passes through, or excuse me, that the line passes through the point 3, 7. Well, it's easy to write the point-slope form of the line. You're just going to write y minus the y-coordinate, which in this case is 7, equals m, the slope, which is in this case 5, times the quantity x minus, and then the x-coordinate, which in this case is 3. And so we have the point-slope form, y minus 7 equals 5 times x minus 3. This is the point-slope form of a line. Now here's the cool thing. You can actually turn point slope, you can take the point slope form of a line and turn it into the slope intercept form of a line by doing some algebra. Let's do some algebra. The first thing you're going to do is you're going to distribute this number, the slope, inside these parentheses. And so we're going to just carry down the y minus 7 equals 5 times x is 5x. There's our slope. Look, there's our mx. It's right there, 5x. Now 5 times, when we distribute the 5 over here, 5 times negative 3 is negative 15, right? We only have one step left. See this over here? This says y minus 7. But in our slope-intercept form, it's supposed to be just y equals with no other number. So we're going to move this negative 7 here. So we're going to add 7 here. We're going to add 7 here. That eliminates the negative 7 on the left side. We're going to carry down the y, carry down the equal sign. We didn't change the 5x, so we're just going to carry that down also. 5x. Now, negative 15 plus 7, well, that's equal to negative 8. And now we have the slope-intercept form of the line, y equals 5x minus 8. Okay? Now, there's actually another way that you could get the slope-intercept form of a line from the point-slope form. You could just plug 0 in for x, because to get the y-intercept is whenever x is equal to 0. So if we just put a 0 here, 0 minus 3 is negative 3. Negative 3 times 5 is negative 15. Add 7 to both sides, and we get negative 8. And then we could put it in the slope-intercept form, y equals 5x minus 8. Okay? So there's a couple ways that you can get the slope-intercept form from the point-slope form. And that's good, because one of the things that I want you to know how to do is this. I'm going to go ahead and erase this stuff here. Erase standard form here. I'm going to leave the formulas for point-slope and for slope-intercept form. Oops, I wanted to leave that. Okay. Plus b. All right. There we go, mx plus b. One of the things that I want you to know how to do is how to transform from point-slope form to slope-intercept form. Okay? In fact, there's 3 things that I really want you to be able to do. It's a 1, 2, 3, 1. It's a 3-step process. The first thing I want you to be able to do, I'll tell you about that in a minute, okay? The second thing I want you to be able to do is write the function in point-slope form. And then the third thing I want you to be able to do is write the function in standard form. Okay? All right? Well, let's talk about this first thing that I want you to do. Okay? And this point-slope form just feeds right into standard form, because you can just algebraically manipulate point-slope form to turn it into standard form. So what is the first thing I want you to do? I want you to be able to identify the slope of a line given 2 points on the line. Once you have, if you're given 2 points, if you're given 2 points that are on the line, 2 coordinates, and then you can use that to find the slope. I'm going to show you how in just a second. Then, once you have the slope, and then you just take one of the points and you write the function in point-slope form, and then you can write the function in standard form. Okay? All right. So how can I show you, or how are you to find the slope of a line? Well, the formula for the slope of a line, if you have 2 points, let's say you're given the points let's say 3, 7, and the other point is 5, I don't know, 5, 15. Let's make it that, okay? So you have these 2 points, and here's what you're told. You have 2 points, and there is a line that passes through both points, okay? So the first thing you should do is identify the slope of this line. Well, slope is rise over run. Rise is the change in y, and we write that as the Greek letter delta, so delta y over delta x. So we can, and the letter delta is often used to represent the word change. Okay, so this means rise is the change in y over the change in x. So going from 7 up to 15, how much did y change by? From 7 up to 15, well, that goes up by 8. So the change in y was 8. Okay, and here going from 3 up to 5, what was the change in x? Well, the change in x is 2. So here our change in y is 8. Our change in x is 2. But there's a formula for it, and this is the formula I want you to use. The formula is y2 minus y1 over x2 minus x1, okay? Where x1, y1 is one of the coordinates, one of the points that's given. And then x2 and y2 is the other point that's given. Now, it doesn't really matter which one that you call x1 or x2, okay? But you just have to make sure that if this one's x1, then this one has to be y1. If you make this one x1, this one has to be y1. Or, yeah, if this is x1, then that's y1. Now, if you make this one x1, then this one has to be x2, and then this one would have to be y2, okay? So let's do this. Let's make 3 x1, and let's make 7 y1, and then let's make 5 x2, and let's make 15 y2. So we just need to plug them into the formula. So here's what we're going to do. Our slope, m, is equal to y2 minus y1. Okay, here, let me write out the formula. y2 minus y1 over x2 minus x1. y2 is 15 minus y1 is 7 over x2 is 5 minus x1 is 3. And now we just do some math, right? 15 minus 7 is 8 over 5 minus 3 is 2, and 8 divided by 2 is 4. And therefore, our slope, the slope of the line that runs through these 2 points, the slope is 4. Now, let's write the equation of that line in point-slope form. Okay, well, let's come over here. Here's the point-slope form. We have a slope. We have 2 points. We don't have to use both of them. You just pick one of the 2 points. So that means you can have 2 possible answers to this point-slope form, but they're the same line. Okay? So here, we're gonna have the y minus y1. Well, even though this one says y1, we don't have to use the one that we chose to be y1. It can be any y value. Okay? In fact, to prove it, I'm going to go ahead and I'm going to use x2 and y2. But in this formula, technically, this is the same thing as y1. This is just the y value. So we're going to use a 15. So y minus 15, because it can be any point. And I already told you that we could have called these x1 and y1, right? Okay. So then we're going to bring down an equals. Now our slope, m, well, we just calculated that. It's 4. 4. And then x minus, and then x1, it has to be the x value that went with that y value, okay? So I can't choose 3 now, because the y value I chose was from this point, so I have to choose the x value from this point, which is 5. There we go. Y minus 15 equals 4 times x minus 5. That's the point-slope form of the line that passes through these 2 points. Now, if If I go over here to the slope-intercept form, I can take this y minus 15 equals 4 times x minus 5, and I can turn this into slope-intercept form like I showed you before. There we go. First thing I'm going to do, I'm going to carry down the y minus 15, and I'm going to distribute the 4. And this is going to become 4x minus 20. Then I'm going to add 15 to both sides. That's going to eliminate the 15 on this side, and I'm going to have y equals 4x. And negative 20 plus 15 is minus 5, making the equation of this line, the slope-intercept equation of the line is y equals 4x minus 5. And that's how you start with 2 points, identify the slope, then write the function in point-slope form, then write the function in standard form. Let's do one more example. We'll do all three of the things. I'm going to let you do, I think you should, once I give you the points, you pause the video and try to calculate it yourself. Okay? All right. Let's say the 2 points are make this one a little more challenging. I didn't erase this because there's something you have to be able to do. Let's say we've got the points 4, 7, and the point 7, 7, 2. Okay? Here's our 2 points. Go ahead and pause the video and try to do the whole thing. Identify the slope, point-slope form, slope-intercept form. Go ahead and try that. Okay, so hopefully you tried it, and here's hopefully what you would have gotten. So we know that the slope is y2 minus y1. Well, we have to decide which ones are going to be y2 and y1. Let's just call this one, x1, and we'll call this one y1, and then we'll call this point x2 comma y2. All right? So it's going to be y2 minus y1. y2 is 2 minus y1 is 7 over x2 is 7 minus x1 is 4. Well, 2 minus 7, that's negative 5. Over 7 minus 4, that's 3. So that means that the slope of the line is negative 5 over 3. And now that we have the slope of the line, we can write the equation of the line in point-slope form. And so we'll have y minus, and it doesn't matter which y value we're going to choose. We can choose this one over here. So y minus 7 equals, and now we're going to put the slope in, negative 5 over 3. So negative 5 over 3 is the slope, parenthesis, x minus, and now the x value that went along with the y value 7 is 4. So we're putting an x value in here, x minus 4, and that is our point-slope form. Now, if we want to turn this into slope-intercept form, this is going to be a little more challenging than it was the first time, but that's okay. It's going to be, we're going to write it, y minus 7 equals negative 5/3 times x minus 4. First thing we're going to do is we're going to distribute this negative 5/3 to the x and to the negative 4. So we'll carry down the y minus 7 equals negative 5/3 times x is just negative 5/3 x. Now, negative 5/3 times negative 4, a negative times a negative is a positive, and 5 over 3 times 4, we're just going to do the 4 times the 5 because numbers that aren't fractions are automatically numerators. Okay, so 4 times 5 is 20, so it's going to be 20 over 3. Now this fraction, 20 over 3, is not reducible in a simple way. Okay, so it's going to stay as 20 over 3. But we have a problem now. We still have to add 7 to both sides. Well, I'm going to add 7 here and add 7 to this 20 over 3. Well, it's going to eliminate the negative 7 on the left side, and it's going to become y equals negative 5 over 3x. Now I'm going to stop here for a second. Do you see this plus 7 here? I don't want to leave it as a plus 7. I need for it to be able to be added to the 20 over 3. Therefore, it needs to become a fraction over 3. Well, 7 as a fraction over 3, well, I'm just going to multiply the 7 times the 3, which gives me 21, and then put it over 3, 21 over 3, because 21 over 3 is the same thing as 7. 21 divided by 3 is 7. Now I have a common denominator, and I can add them together. So now 20 plus 21 is 41, and now the common denominator is over 3, and now I have my slope-intercept form. Y equals negative 5 over 3x plus 41 over 3. Okay? So this is something that you have to be able to do. You got to be able to identify the slope, then write the function in point slope form, and then write the function in standard form. Okay? Well, good luck with that, and I will see you later.